Hi, we're going to talk about principles of physical training in this video series. So we're going to start with the training basics. And so to learn about the basics, we really have to know about the basics of the body. So we're going to learn about the framework, the power, the fuel, the energy, and how we control our body. So the framework is kind of the base of it all. And our framework for our body is our skeleton. And so over here you see a human skeleton. And a human skeleton was built for movement. It's designed with movement in mind. So if you look over here at this bone, you'll notice the outside of this long bone. This is the femur bone. If you look at this bone, the outside is very thick and it's solid, and it's thick and it's solid because bones need to be very hard, and that prevents breaks. So if this wasn't as thick and as hard, we would experience a lot more breaks because a small hit could cause it to break. Now you notice the inside is hollow, and so there's not much inside the long bones, and that's because we also need them to still be light, even though we need them to be tough. And it's important to be light because if they weren't light, then our bones would weigh us down, and it would make it difficult for us to even take a step anywhere because it would take so much energy and ATP to even walk to the sink. And so our bones have this beautiful design that is hollow on the inside and hard on the outside so that they're light but hard. There are 206 bones in the human body. Yes, you heard me correctly, 206. The good news is you don't need to memorize all 206 for this class. Now, for anatomy, you probably will have to, or at least the majority of them. But for this class, I have listed some common bones. Many of these you may already know about, but these are some of the most common bones in the human body. So we have here femur, tibia, fibia, clavicle, humerus, radius, ulna, and pelvis. You need to know those. You need to be able to find them on a skeleton and identify them. So the next thing we're going to move on to is how we manipulate or move that skeleton. And that's what creates the power in our body. And so the power is created by our muscles. And there are 640 muscles, give or take a few. There are arguments over whether this is just one muscle or maybe two muscles, but there are about 640 muscles in the human body. And we need so many muscles so that it allows our body to move in lots of weird ways in different directions and give us a lot of mobility. There's so many muscles that it makes up 30 to 40% of our body weight is all in muscles. And so how muscles work is they create movement by pulling on our bones when they contract. Okay, so I have an example here for you when it comes to this. I have a golf club. That is going to be our bone or the skeleton. And then I have this rope, just a regular rope, and that's going to be our muscles, all right? So it's going to expand and contract. And so I'm just going to attach the rope to this golf club so that we can pretend it's the bone, because our muscles are attached to our bone. And so if this is a bone and this is our muscle, if the muscle contracts, what's going to happen to this club? It's going to move. So when I lengthen it or shorten it, the length, or contract the muscle, it causes this golf club to move. That's the same thing that happens in our body. When I contract my muscle, it causes my bones to be moved due to the contraction or that shortening of my muscle. That contraction or shortening of muscles is what actually generates force. And so force is produced by muscles contracting. Now here are the muscles that you need to know for this course. And so I'm not going to make you know all 640. Maybe one day you'll know them all. But these are common muscles that you need to know about. So you see we have the deltoid, the rotator cuff, the biceps brachii, and the triceps brachii. I do want to point out with the rotator cuff that is a group of muscles, okay? The rotator cuff is a group of muscles that surround our shoulder, and they help keep our humerus head in socket or in place. And so there are actually 4 muscles, if you see right here, 4 muscles that make up the rotator cuff: the subscapularis, supraspinatus, infraspinatus, and teres minor. And so I like to remember these as these SIT, S-I-T-S. Supraspinatus, infraspinatus, teres minor, and subscapularis. And that's the muscles that surround our shoulder. Those are all upper arm muscles that you need to know about. The trunk, meaning the core, the middle of our body, you need to know about the rectus abdominis. The obliques, they're actually external and internal obliques, and those are just different based on the direction that the muscle fibers run. So some muscle fibers run this way, up and down, and others run the exact opposite way, from up to down rather than from down to up. And so there's some running this way and some running the opposite way, making a little crisscross. And then the trapezium is a large muscle on our back. Then for the upper leg, you need to know about the gluteus muscles. So there are 3 gluteus muscles: the gluteus maximus, medius, and minimus. So the maximus is the maximum, biggest size, and the minimus is the smallest one, the smaller size. They're actually layered. The maximus is on the outside of our bum, and then right below it is the medius, and the minimus is even further below it. The quadriceps femoris, it gets its name quad, meaning 4, because it is 4 muscles. So there's the rectus femoris, vastus lateralis, vastus intermedius, and vastus medialis. There are also the hamstrings, which are 3 muscles: the biceps femoris, semitendinosus, semimembranosus. And then the last set of muscles are the lower leg muscles that you need to know: the gastrocnemius and the soleus. And those 2 are the muscles that make up the calf. So here is a link that you can follow. It's free using your Gmail account, and it allows you to look at these muscles in 3D on a human body. These muscles are all the muscles you need to know. You need to know what action they produce, and you need to be able to identify them on a human body, all right? So a little muscle man or woman. Okay, so now we're going to talk about fueling the body. And so to learn about fueling the body, we're going to start with the heart. The heart beats 100,000 times every single day. So in a person's lifetime, the heart beats about 2.5 billion times. All right, so why do we care about the heart when we're talking about fuel? Well, the heart, its job is to pump blood or move blood throughout our entire body. And it moves blood throughout our entire body because blood moves through these vessels. These vessels go all over our entire body. In fact, these vessels make up 60,000 miles. If we were to lay them out one after another, it would go the length of 60,000 miles. That's how many of those we have. And so it takes fuel or nutrients to every single part of our body, and then it takes waste products and takes them away from wherever they're at to their location that they need to go to. And so interestingly, as athletes, our body actually develops and changes because we use it more frequently and need to move nutrients more and more than the average person. So if you notice here, endurance athletes pump about twice as much blood per heartbeat than the average person does. And this is because the heart is just another muscle. Endurance athletes train it regularly when they're doing their endurance sport, whatever sport that may be. And so their heart is very strong and very powerful, and with each pump, it can expel more blood than the average person's. And interestingly, we even change how we distribute blood throughout our body. So right now we're at rest, or we're relaxing. So about 15 to 20% of our blood in our body is going to our large muscles, like our hamstrings, our triceps, our biceps. But once we start exercising, doing strenuous exercise, that changes. And our blood no longer is going to things like our stomach to digest our lunch. It diverts that blood to our muscles. So it sends 80 to 85% of the blood in our body to our muscles so that it can deliver the amount of nutrients, including oxygen, that it needs to produce energy. Okay, so what is this energy that we're talking about? This gives me this like Lion King circle of life type of thing when I think about energy. So all the energy comes from the sun, right? The sun produces energy via the photons it sends down to planet Earth. And so that energy comes down and it is turned into trees, right? Or plants, not necessarily a tree, but the plants on our earth take that sunlight energy and convert it into leaves and things of that nature. Then we eat those plants. Maybe you eat more meat and less plants, but in that case, an animal would be right here. An animal would eat the plants, and so the energy would be converted from plant to animal, and then we would eat the animal. But either way, it's the same way. Then humans, us, we eat that energy. Then our body is really cool because it converts that food that we digest and it converts it to chemical energy. And so it breaks down that food into small molecules and it even reorganizes them and puts them back together. And then it sends, eventually we'll talk about the ATP, but it eventually sends ATP to our muscles for use. And when we use that energy, that's the movement that's happening. That's that force, that power. So it's this big circle of life where our energy to move comes from. So how do we actually move? So that's happening because of our central nervous system. And our central nervous system is the command center in charge of our entire body. The central nervous system is made up of our brain, our spinal cord, and then our peripheral nerves that run all throughout our body. Makes up about 93,000 miles, a long thing if we strung it together. And so let's look at this model over here. It does a really good job of describing what happens. And so there's a stimulus of some sort. Something happens. This is an example of someone shooting a gun at the beginning of a track race. So that information, that stimulus, gets heard. In this case, you use your ears, and it turns it into sound and sends that signal to our cerebral cortex in our brain, this part of the brain right here. That information that, oh, the gun went off, is received, that stimulus is heard, and then a motor program begins, which is like a set of rules, what should happen. And that is, in this case, to run, right? To sprint for the sprinter. And so that information is collected here in the cerebellum, and then it is sent throughout the spinal cord. So it travels down the spinal cord and then out the peripheral nerves to the muscles that make us sprint. And so the muscles start contracting so that the legs can start moving and sprinting really fast. And so while that seems like a lot and a long process to occur, all of this happens within less than a second. It's very, very, very quick how these things occur. Okay, so the rest of this PowerPoint I'm going to need you to go through on your own, but I want to point out a couple of things to pay especially close attention to. Okay, so the components of health-related fitness you should already know from personal health, which you had to take before you could take this course. Then there are also some skill-related components to fitness. So this is different than the health-related components. The skill-related components are really important to us as coaches working with athletes. So for athletes, this tends to be really important. So these are things like agility, balance, power, speed, coordination, and reaction time. These make the difference for athletes. This is what makes an athlete more skilled. And so these are kind of difficult sometimes for students to remember. And so I came up with this little acronym to remember it. So you can remember crabs P. All right, everybody pees, so of course crabs pee. But C, coordination, R, reaction time, A, agility, B, balance, S, speed, P, power. Crabs pee. So think of that when you're thinking of the skill-related components of fitness.